Let's take a look at factorization of trinomials where your a is equal to 1. This is something that was covered in grade 9, so hopefully it should feel quite easy. So for those grade 9s who are watching, this one is for you. So trinomial forms take the form of an ax squared plus bx plus c. Now there are two ways to do this. There is the part where a is equal to 1, which is what we're going to look at in this video. And in our next video, we're going to look at when a doesn't equal 1. And of course, there's various techniques for factorizing trinomials. And there are a lot more when a doesn't equal 1, and we'll cover that in a few minutes. So let's find factor pairs of a number. So here, I'm going to show you a great trick that you can do on your calculator. So we want to find the factor pairs of 48. So on your calculator, you're going to press mode and you're going to choose 2 for table. Now we type in 48 and we press our fraction button, this a/b, and we make an X underneath it by pressing RCL. Here we go. I'm just moving it so that you can see you don't actually have to do that. Then we press equals, 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 and you'll see that you have a series of factors. So we've got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6. So we can see 5 is not a factor because it has a decimal in its answer. 6 and 8, 7 and 6. So now we can see that x is more than answer, and we have found all of our factors. Cool. So from there, let's do some examples. So before we can continue with difficult examples, I want to show you an easy example first. And that is to do with the rules of trinomials and factorizing the signs. So you will see that I've written it as ax squared or just normal x squared because in this case, a is actually equal to 1. So what we do is we look at the sign in front of our c value here. Or in our examples, it would be this sign here, right? So when the sign in front of the c is a positive, then we know that our brackets have the same signs. Okay, so here and here, our brackets have the same signs. How do we know which sign? Well, we look at the sign in front of our b value, the thing attached to the x. So here it's plus, and in this example, it is minus. So both brackets have a minus sign. When your sign or your c value is a negative, then your signs are different. And I'll explain how to do that in a second. Let's go back to our first two examples. So here, because our signs are the same, it's quite so straightforward. We would find the factor pairs of 8. So I'm just going to write them down quickly. So it's 1 and 8, 2 and 4, 4 and 2, and 8 and 1. Okay. So we need to, because the sign at the back says plus, we have to add the two factors together to find our middle term, which is 6, right? So does 1 plus 8 equal 6? No, it doesn't. 2 plus 4? Yes, it does. So we can use these factors. So here we would have x, our sign is plus, 2, and x, our sign is plus, and 4, and we are done. Again, we have x squared minus 9x plus 8. So if we look at our factors, I'll just write them down again. So it's 1 and 8, 2 and 4, 4 and 2, and 8 and 1. So here our sign at the back is plus. So again, we're adding our factors to get our middle term, and both the signs of our factors are negative. So we can just say, is 1 plus 8 equal to 9? Yes, it is. So I've got x minus 1 and x minus 8. And now I factorize my trinomial. Lastly, when we have a sign at the back that is a negative, it means that one of my columns is going to be a plus and one of my columns is going to be a minus. And we would say plus 1 minus 8 equals minus 7, not minus 2, so not what I'm looking for. Plus 2 minus 4 gives me minus 2. That is what I'm looking for. So I can say x plus 2 and x minus 4, and I'm all done, and I have factorized my expression or trinomial. Let's do another example. So here we've got x squared plus 12x plus 35. So plus tells me that it is same sign, so I can write down my brackets. And I've got x, and my signs are both pluses because the plus in front of the b. Now I find the factor pairs of 35, and I can see from my table here that that's 1 and 35. 2 is not a factor, 3 is not a factor, 4 is not a factor, 5 and 7. And we can see that 6 is bigger than our answer, so we found all of our factor pairs. So we could also alternate here and just mirror it through as well. Okay, so 1 plus 35, does that give me 12? No, it doesn't. 5 plus 7 does give me 12, so I can write down 5 and 7, and I have now factorized my trinomial. Let's do one more example just for good measure. So here we've got x squared plus 7x minus 44. So minus tells us different signs. Okay, so we're going to go look for our factor pairs. We can see that we've got 44 over x, and our factor pairs are 1 and 44, 2 and 22, 3 is not a factor, 4 and 11, 5 is not a factor, 6 is not a factor, and 7 is bigger than our answer. So we've got all of our factor pairs written down, and now we just mirror it. So we write 11 and 4, 22 and 2, and 44 and 1. Okay, so we need to find 7. So I'll make this column plus and this column minus. So plus 1 minus 44 does not give me plus 7, so that doesn't work. Plus 2 minus 22 gives me minus 20, so that one doesn't work. Plus 4 minus 11 gives me minus 7, so that's the right combination but the wrong sign, so that doesn't work. Plus 11 minus 4 does give me plus 7, so that is my combination of factors. So now I can write x plus 11 and x minus 4, and I'm done. It's a nice technique, isn't it? It's quite easy to follow and use. So join us for our next video where we talk through or work through the different ways to factorize trinomials with a not equal to 1, which is a little bit harder, but there's so many great techniques that you're sure to find something that works well for you.